Imagine pushing a single line of code, getting up to grab a coffee, and, by the time you sit back down at your desk, that code is just live.
Right.
Live in a production SAP Business Technology Platform environment.
Yeah, out in the wild.
Exactly. It's handling millions of dollars in enterprise transactions, and absolutely zero human beings checked it along the way.
Which sounds completely insane to a lot of people.
Right. Terrifying.
Well,
right. Or, well, maybe it's the ultimate utopian goal of modern software engineering.
I'd argue it's the latter, definitely.
Welcome to the deep dive. Today, we are stripping away the generic, high-level fluff you usually hear in keynote speeches about agility and synergy and all of those buzzwords.
Oh, yeah. We are getting into the actual mechanics today.
Exactly. If you are sitting there staring down the barrel of a massive overhaul to your organization's deployment architecture, well, consider this your highly structured, intensive blueprint. We are talking about actually mastering DevOps and CICD within SAP BTP.
And it really is the defining line between an organization that merely survives the transition to the cloud and one that actually leverages it. Because the reality of building on SAP BTP, whether you're deploying extensions via Cloud Foundry or running microservices on Kaima.
Right, whichever route you take.
Exactly. Understanding the theory of DevOps is completely useless if you don't know how these concepts manifest in actual pipelines.
Yep.
You need to know the team structure and the specific configurations you actually have to build.
Okay, let's unpack this. We have to start with the foundational friction that makes DevOps necessary in the first place, I think.
Yeah, the root of the problem.
So Ken McGrath, he's the Chief Technology Officer at ThoughtWorks. He has this incredibly potent definition.
I love his take on this.
It's so good. He frames DevOps not as a tool chain, but as a culture where people, regardless of title or background, work together to imagine, develop, deploy, and operate a system.
Right, a unified front.
But let's be real here. Historically, in the enterprise space, people with different titles absolutely do not work together.
No, not at all.
They operate in these massive, heavily fortified information silos.
Fortified is the perfect word for it.
Right.
Because in a traditional enterprise architecture, these silos aren't just cultural, right? They are structural. And they're incentivized by completely opposing metrics.
Yes, the metrics are key here.
We all know the classic divide between the development team and the operations team. But look at how they're evaluated.
Right. What are they actually graded on?
Exactly. The mandate from the business for a developer is velocity. They are measured by the net new features they can produce and just push toward the end user.
Right.
Their entire professional existence is geared toward creating constant, relentless change.
Right. They are basically the agents of chaos.
Pretty much.
They build something shiny, and their immediate instinct is, push it live so we can get user feedback.
Always.
But then you look across the chasm at the operations team.
The people who have to actually clean up the mess.
Right. The people who actually have to run this code on the SAP runtime, they aren't measured by new features.
No, not at all.
They are measured by uptime, by system stability, by making sure the core ERP integrations don't just spontaneously collapse at 3 in the morning on a Sunday.
Exactly. And from an operations perspective, you have to ask, what is the single greatest threat to system stability?
It's change.
It is change. Every single time the development team hands over a new deployment package, the ops team views it as a massive hostile risk vector.
Like a bomb being handed to them.
Basically, yeah. So you have a fundamental organizational paradox.
Yeah.
One silo whose literal job is to force change.
Right.
And another silo whose literal job is to resist change. Development says, I own the application.
And operations says, well, I own the application runtime.
Precisely.
It's sort of like, think of a high-end restaurant.
Okay, like this.
The kitchen is trying to serve molecular gastronomy, right? Liquid nitrogen, foams, wildly experimental dishes.
Right, the cutting-edge stuff.
But the waitstaff is only trained and equipped to carry standard burgers and fries.
Oh, man. Yeah.
So if the kitchen just throws a smoking, freezing plate through the swinging doors, the waitstaff is going to drop it.
Instantly.
The dining room is going to panic, and the restaurant basically burns down.
Yeah, chaos.
The biggest risk to the business isn't actually inside the kitchen, and it's not inside the dining room. The biggest risk is the swinging doors between them.
And in the IT world, those swinging doors are made even heavier by the fact that the two sides speak entirely different languages.
Oh, completely.
They use different logging tools, they look at different monitoring dashboards.
Right.
And fundamentally, they lack a shared definition of what the word done actually means.
Oh, that's a huge point.
To the developer, done means the code compiles on their local machine.
Yeah, like it works on my laptop, so we're good.
Exactly. But to the operations engineer, done means the code is running stably in production, it's backed up, and it's actively monitored.
Two totally different universes.
Exactly.
So if the problem is the swinging doors, DevOps is basically the methodology of taking those doors completely off the hinges.
Yes.
It rejects functional silos entirely. But, how does that actually look in a practical team structure?
Right. On the ground.
Because you can't just put a developer and an ops guy at the same desk and say, all right, now you are DevOps.
No, you really have to restructure around the product's actual value stream.
Okay, what does that mean?
So a true cross-functional autonomous team includes everyone who contributes to the value of that specific product from inception to operation.
Everyone.
Everyone. The term DevOps is actually a bit too narrow for what it demands.
Because it leaves people out.
Right. It's not just dev and ops. It requires quality assurance.
The QA, yeah.
It requires user assistants, user experience designers, and product managers.
Wow, okay.
You put them all in the same boat, structurally and operationally, and they are focused on the exact same lifecycle.
But wait, if you suddenly put QA, UX, dev, and ops on the exact same team, aren't you going to have just massive culture clash?
Oh, initially. Absolutely.
Right, because if the QA person defines a successful deployment differently than the product manager, the whole pipeline is going to grind to a halt before it even gets to the code repository.
What's fascinating here is that this is why true DevOps demands a monumental cultural shift.
Okay.
It's moving from avoiding failure to seeing failure as a learning opportunity.
That's tough for a lot of legacy companies.
It is. This is a shift from heteronomy, where teams are controlled by external rigid rules imposed by distinct management chains, to true autonomy. And you cannot buy this from a vendor.
You can't just install a DevOps plugin.
Exactly. You can buy BTP services that enable it, sure. But if your leadership still punishes an operations engineer every single time a developer's code causes a blip.
Right, if there's still a blame game.
Yeah, your technical pipeline will fail because the human behavior simply won't support the required transparency.
Which means we really need a diagnostic tool here.
We do.
We can't just mandate better culture in a vacuum. If you're out there architecting an SAP environment, you need a way to actually measure your readiness.
Yes, you need a baseline.
And this is where the CalmS framework comes in. CalmS, coined by John Willis, Damon Edwards, and Jez Humble.
It's brilliant.
It really is the gold standard diagnostic for DevOps in practice. So let's break this down for you. Not as a boring checklist, but as a holistic system.
Let's do it.
It starts with C for culture, which we just touched on, but specifically moving from a project mindset to a product mindset.
That distinction is so critical.
Yeah.
A project has a definitive end date. You build the bridge, you cut the ribbon, you walk away.
Right. Job's done.
But a product has a continuous life cycle. It is never truly finished.
Because it's software.
Right. It is constantly evolving based on user feedback. Part of shifting to that product mindset involves actionable transparency, like working out loud.
Working out loud.
Yeah, making your daily work, your architectural challenges, and your progress entirely visible to the rest of the cross-functional team.
One of the most fascinating cultural tactics I've seen implemented here is this concept of screw-up nights.
Oh, they are incredibly effective.
Yeah.
Yeah. A screw-up night is a formalized, regular event where team members, and especially senior engineers and architects, this is key.
Right. The leaders have to do it.
Exactly. They stand up and present their biggest professional failures.
I love that.
They explain exactly how they broke a production system, what the cascading effects were, and crucially, what they learned.
Right.
And how they engineered a safeguard to prevent it from happening again.
That's amazing.
It mathematically destroys the fear of failure. It normalizes errors as inevitable stepping stones to system optimization.
Okay, so let's say we fix the culture. The C in calls is good.
Great.
Everyone is talking, the waitstaff and the kitchen are collaborating, and people are openly admitting when they drop a plate.
Love it.
But if they're still manually carrying those plates...
Uh-oh.
Yeah, if they are still manually executing deployment scripts and configuring BTP destinations by hand at 3 in the morning...
Yeah, that's bad.
That new culture is going to fracture immediately from sheer burnout, right?
100%.
Which brings us to the A in CalmS, which is automation.
The mandate here is absolute. You have to automate everything possible.
Everything.
Everything. testing, configuration, infrastructure provisioning, and operational remediation.
Okay.
We are talking about utilizing infrastructure as code, setting up highly reliable CI/CD tool chains, utilizing SAP continuous integration and delivery, and leveraging virtualization heavily.
Like what?
Like running containerized workloads on Kubernetes, for example.
Okay, I have to push back here, though.
Go for it.
Because automate everything sounds like a really dangerous catch-all to me.
How so?
Well, if a team has a fundamentally flawed, bloated, terrible manual QA process, and they just automate it, haven't they just created a highly efficient machine for doing the wrong thing?
Yes.
Is automation purely about speed?
That is the exact trap many organizations fall into.
Right.
Speed is merely a byproduct of good automation. The actual architectural goal is reducing cognitive load and enforcing consistency.
Consistency, okay.
Right. If you have a human being execute a complex deployment sequence 50 times, eventually they will make a typo.
It's just human nature.
They will be fatigued or distracted by a Slack alert.
Mm.
But an automated script, it will execute the exact same sequence flawlessly a million times.
Right.
It yields repeatable processes.
Mm.
In a mature environment, human intervention in a repeatable process should be viewed as a critical bug, not a feature.
Okay, which perfectly bridges us to the L for lean.
Yes.
Adopting lean principles and systemic thinking. So what does this all mean? If we don't want to automate a bloated process, we have to lean it out.
Exactly.
We have to eliminate waste and focus purely on value delivery. But mechanically, what does that mean for a developer working on a BTP extension?
It fundamentally changes their batch size.
Batch size.
Yeah. Instead of spending 6 months building a monolithic update in a silo and then throwing this massive untestable beast over the wall.
Which is the old way.
Right. Lean dictates that you deliver in small, highly digestible chunks. You build quality intrinsically into the process from day one.
Rather than what?
Rather than trying to bolt it on at the very end during a massive, painful QA phase.
Right.
Tiny batch sizes mean you gather fast customer feedback. And if something breaks, the blast radius is incredibly small and easy to identify.
But wait, if we are deploying hundreds of tiny changes instead of one giant change, how do we keep track of whether we are actually improving or just, spinning our wheels?
That is the big question.
Which brings us to M for measurement, data-driven ops.
You can only improve what you can measure.
Yep.
Without transparency across the entire application lifecycle, you are basically flying blind.
So what do we measure?
We rely heavily on the DORA metrics, DevOps research and assessment.
Right.
These are the industry standard for a reason. First, deployment frequency. How often are you actually pushing code into a production environment?
Makes sense.
Second, lead time for changes. From the exact moment a developer commits a line of code, how long does it take for that specific line to be running in production?
Wait, I can see a flaw in relying purely on deployment frequency, though.
Oh, yeah.
Yeah, because if I'm a developer and I know I'm being judged on frequency, I'm just going to push meaningless, tiny updates.
Like a typo fix.
Right, like changing a font color back and forth just to juke the stats and look productive.
Which is exactly why you cannot measure frequency in isolation.
Ah, okay.
You must balance it with the third DORA metric, which is change failure rate.
Change failure rate.
Right. What percentage of those deployments actually cause a degradation or a failure in production?
So it keeps you honest.
Exactly. If you are deploying 50 times a day, but 20 of those deployments break the system, your high frequency is actually a huge detriment.
That makes total sense.
And the fourth metric is time to restore service. When that inevitable failure happens, how quickly can you recover?
We also look at MTBF and MTTR, right?
Yeah.
Mean time between failures and mean time to repair.
Yes, MTBF is a core measure of your system's reliability. Basically, how long does the system run perfectly before something degrades?
Right.
MTTR tracks your organizational resilience. Historically, in a siloed architecture, MTTR can be measured in days.
Days.
Yeah, because the ops team first had to realize there was an outage, right? Then crack down the dev team.
That love.
Then figure out what was even in the deployment package, and then try to reverse engineer a fix.
A nightmare.
But in a mature DevOps environment, because the changes are tiny and the deployment is automated, your MTTR should shrink to minutes.
Just minutes.
Yeah, you just automate a rollback to the previous known good state.
Wow. And finally, we have the S in calmness, sharing.
Yes, sharing.
This closes the loop, really. Actively fighting knowledge silos through extreme transparency.
Is vital.
One of the most actionable ways this manifests at the developer level is pair programming, isn't it?
Pair programming is relentlessly effective.
How does it actually work in practice?
It's two developers, one screen, one keyboard.
Okay.
One is driving the code, the other is navigating and reviewing in real time.
It sounds kind of intense.
It can be, but it ensures instantaneous knowledge transfer, and it drastically elevates code quality because every single line is immediately peer-reviewed.
That's true.
And psychologically, it naturally breaks down the walls of my code versus your code. It becomes our code.
So if we synthesize this whole Kuramas framework for you listening right now, if you are mapping out your BTP architecture and you just go out and buy an automation tool, but you don't change the culture.
Right.
You don't apply lean small batches, you aren't measuring DORA metrics, and you aren't sharing knowledge, what do you actually end up with?
You end up with a disaster.
Really?
Truly. If you build a sophisticated CI/CD pipeline without implementing lean principles and rigorous measurement, you have not achieved DevOps.
What have you achieved?
You have simply engineered a highly efficient, automated pipeline for deploying broken code into your production environment at lightning speed.
Oh, wow.
You will literally take down your enterprise faster than ever before.
Okay, that is a terrifying but incredibly necessary warning.
It is.
So Kalamas gives us the philosophy, the metrics, and the cultural guardrails.
Yes.
But if we don't have a mechanical engine to enforce this reality every single day, it all just falls apart.
Exactly.
So let's transition to that technical engine, continuous integration or CI.
Continuous integration is the absolute non-negotiable foundation of this entire workflow.
Period.
Without CI, there is no DevOps.
Okay, let's define the mechanics clearly. CI is the software development process where various team members frequently integrate their individual contributions into a single centralized main line.
Right.
And crucially, before each integration is finalized, the changes are verified through automated builds and testing.
That's the key.
The primary architectural goal is to detect integration errors the very second they are introduced.
Yes, because the life cycle of a bug dictates that the longer an error lives in the code base unnoticed, the more exponentially expensive and complex it becomes to extract.
Right, it gets tangled up.
Exactly.
Right.
CI is designed to trap the error in the smallest possible context. To achieve this, we rely on three vital principles.
Okay, principle one.
Principle one, use version control.
The source code management system, or SCM.
Yeah.
In modern enterprise environments, we are almost always talking about a Git-based repository, right?
Exactly. When you have multiple engineers working on a complex SAP extension simultaneously, the SCM is your absolute single source of truth.
The one and only.
It defines the common mainline for the product's source code, and that mainline serves as the basis for all further development.
Right.
Think of it as the master ledger of the application's history.
And it is a very meticulous ledger.
Very.
Every single time a change is made, the SCM tags it with a timestamp. It permanently logs the cryptographic identity of the developer responsible, and it enforces a commit message explaining the intent of the change.
Which is vital not just for collaboration, but for enterprise auditability and compliance.
Right, for the auditors.
It makes every contribution entirely transparent. If a deployment catastrophically breaks the integration suite, you don't have to guess who changed what.
No more pointing fingers.
Exactly. You look at the SCM, identify the exact commit that introduced the instability, and you can instantly roll the mainline back to the previous stable version.
Which brings us to principle two, and here's where it gets really interesting.
Right.
Because this is where the actual gatekeeping happens. Build each change.
Yes.
The main line is treated as sacred.
Absolutely sacred.
It must be protected from bad code at all costs. To do this, we use something called a voter build.
Voter builds are amazing.
Now, I have heard voter builds described as testing a bucket of water before dumping it into a pristine reservoir, but that metaphor feels slightly mechanically flawed to me.
Really? How so?
Well, because a voter build doesn't just test the new code in a vacuum before it goes into the main repository.
Right.
Mechanically, it's more like taking a perfectly cloned miniature replica of the entire reservoir.
Ah, I see where you go.
Adding that new drop of water to it, observing if all the fish survive the new mixture, and then, only if the ecosystem remains stable, allowing that drop of water into the real main line.
That is a vastly more accurate way to visualize it, yeah.
It makes more sense.
Totally. A voter build automatically takes the developer's proposed code change, spins up an isolated, ephemeral environment.
Like what?
Like deploying a temporary pod in a Kaima cluster, for example.
Okay.
It merges the proposed change with a copy of the current mainline and runs a battery of automated unit and integration tests against that specific combination.
So it literally votes on the outcome.
It literally votes. It provides immediate, emotionless feedback back to the SCM.
Emotionless is a good word for it.
Right. It says, yes, this code compiles. It passes all automated tests. I vote to allow the merge. Or it says, no, this change breaks a core dependency in the replica environment. I vote to reject it.
No merge for you.
Exactly. This guarantees that you find out if a project is broken from a build perspective before you ever endanger the sacred main line.
Right.
It entirely removes the human subjectivity from code review.
That makes sense mechanically. But culturally, how do you get senior developers to accept a machine abruptly rejecting their work?
It takes adjustment.
Which leads right into principle 3, I guess. Commit early and often.
This is often the most behaviorally difficult principle for legacy developers to adopt.
Why is that?
Historically, a developer might check out a branch of code, retreat to their local machine, and work on a massive new feature for 3 solid weeks.
Just totally dark.
Yeah, completely in isolation before attempting to integrate it back into the centralized system.
And what is the mathematical reality of trying to merge 3 weeks of isolated code?
It is absolute chaos.
I can imagine.
It is a guaranteed nightmare. The principle states that in collaborative development, the longer a developer waits before integrating their changes, the further their local copy of the code drifts from the original main line.
Right.
While our developer was working in isolation for 3 weeks, their 10 colleagues were committing early and often.
So the code base changed under them.
Exactly. The main line has evolved. The architecture has shifted.
It's like leaving your hometown for 20 years, right?
Yeah, okay.
Coming back with a map from your childhood and expecting to navigate perfectly.
Good luck.
But the city planners have rearranged all the streets, demolished your house, and built a highway.
That's exactly it. And trying to force your old map onto the new city result in massive, catastrophic merge conflicts.
It just doesn't fit.
The risk of these conflicting changes rises exponentially with every single day you delay integration.
So what's the directive?
Therefore, if you want your BTP pipelines to survive, you must force a policy of committing early and often. Developers must break their work down into minor, digestible changes and integrate them frequently, starting at the very earliest stages of feature development.
I want to highlight a massive misconception here, though, because it trips up a lot of architects, and I know it was in the course material.
Yeah. What is it?
The principle is commit early and often. The goal is not to integrate directly into the mainline blindly just to keep your frequencies high.
That is a critical distinction.
Right. You don't just shove your untested code into the main line because you want to hit a DORA metric.
No, absolutely not.
You submit your code to the voter build early and often.
Yes.
The voter build is the essential, non-negotiable gatekeeper. If you integrate directly without that automated vote, you are violently violating Principle 2, you will pollute the main line, and your CI pipeline will collapse.
Exactly. So we have the philosophy, we have the CONMES framework, and we have the 3 core principles of CI. Yep. But this raises the ultimate question, how does this actually look in motion?
In real life.
Right. How do these principles map out in a sequential flow on a Tuesday morning when a developer finishes typing a function?
Let's map it out for you. Let's trace the literal, step-by-step architectural flow of a CI/CD pipeline, and specifically identify the actors responsible at each stage.
Let's do it.
There is a precise 6-step flow. Step 1, code change.
The actor here is the developer. The developer writes the code locally based on the absolute latest version of the main line and pushes those code changes to a designated branch on the central SCM.
Simple enough. That push event triggers step 2, voter build and tests.
The primary actor here is the CI server, which is triggered automatically by a webhook from the SCM.
Okay.
The CI server spins up that isolated environment and runs the voter build we just discussed.
Right.
But it's important to note that in enterprise environments, collaboration platforms like GitHub, GitLab, or Jared Code Review operate alongside this.
What do?
They collect qualitative feedback from human code reviewers, other developers acting as peers, to accompany the purely quantitative automated test results.
So it's an automated binary vote on the compilation and unit tests, potentially augmented by a human review for code quality and logic.
Exactly.
Okay. Once the voter build flashes green and passes step 2, we move to step 3, merge into the main line.
The code change is now formally integrated into the sacred main line, creating a brand new baseline for all future development.
And who does this?
Depending on the organization's governance policy, this merge is either executed automatically the very second the voter bill passes,
Okay.
or it is triggered manually by a designated actor, like a lead developer, a reviewer, or a team architect.
Which brings us to step 4. And we need to clarify a nuance that confuses a lot of people here.
Oh, I know what you're going to say.
Step 4 is the CI build and tests. Wait, didn't we literally just build and test the code in step 2? Why are we burning compute resources to do it again?
It sounds totally redundant, right?
Yeah.
But the architectural purpose is entirely different.
Explain that.
In step 2, the voter build tested the proposed change in a temporary replica to see if it was worthy of joining the mainline. Step 4, the CI build, is triggered after the merge has occurred.
Yeah, after.
Yes. It tests the overall holistic build integrity of the actual new mainline.
Why would the mainline fail if the replica passed, though?
Because in a highly active environment, time is a huge factor.
Okay.
Between the exact moment your voter build started and the moment your code actually merged, another developer might have merged a different piece of code that subtly conflicts with yours.
Oh.
Right? The CI build verifies that the sum of the parts works together in reality.
That makes total sense.
Technically, the compilation procedure might look identical, but contextually, you are proving that the main line itself is still solid and uncorrupted after absorbing your new ingredient.
I see. It's like you taste the hot sauce in a spoon to make sure it's good. That's the voter build.
Right.
Then you stir it into the giant pot of chili and you taste the whole pot of chili to make sure you didn't ruin the entire dish. That's the CI build.
Precisely. That's exactly it. And after step 4 completes successfully, your change is fully safely integrated. Now, if your organization is only practicing continuous integration, the automated process stops right here.
Okay.
The cycle loops back to step 1 for the next code change.
But what if we want more?
If you are advancing into continuous delivery, we push forward to step 5, acceptance tests.
In step 5, the CI server takes that successful build and automatically deploys it to a dedicated acceptance test system.
Yes.
And crucially, this environment cannot just be a generic container, right?
No, absolutely not.
It must be a high-fidelity mirror of the live production environment. If you are deploying to SAP BTP, this test environment needs to have the same destination configurations, the same connected SAP agent database schemas, and realistic mock data.
Exactly. And because these comprehensive acceptance tests, which often include end-to-end UI testing and heavy integration checks, are incredibly time-consuming, this system must remain absolutely stable and undisturbed during execution.
Undisturbed?
Right. You cannot have the CI server constantly deploying new micro-updates into the acceptance environment while a 3-hour test suite is running.
It would ruin the test.
It will completely invalidate the results.
So how do you manage the traffic jam? If developers are committing early and often, but the acceptance test takes hours.
You have 2 actionable paths to configure this flow.
Okay, path 1.
Option 1. You implement a scheduled automation that gathers all the successful CI builds from the day and deploys them to the acceptance environment at a fixed time, say midnight, and runs the massive test suite overnight.
Classic nightly build.
Exactly. Option 2. A specific human actor, the quality manager, manually reviews the integrated changes and explicitly triggers the acceptance testing for consciously chosen release candidates.
This highlights that even in a highly automated CI/CD pipeline, you are not entirely handing the keys over to the robots yet.
Not yet.
You still need human oversight for qualitative acceptance.
Right.
So assuming the build survives the rigors of step 5, we arrive at the final destination. Step 6, manual deployment to production.
A human explicitly decides to release the software version to the live user base.
The actor here is the delivery manager, or potentially an application operator.
Yep.
They look at the audit trail, they see the green lights from the voter build, the CI build, and the acceptance tests, and they take ultimate responsibility for the shipment.
They own it.
They push the final button to deploy to the live SAP BTP space.
Let's pause and explicitly recap the designated actors in this 6-step flow, because if you are architecting a team around this, clarity of roles is paramount.
Go for it.
We have the developer, the SCM, the CI server, the quality manager, and the delivery manager.
I want to point out a very specific omission for you listening, because this was actually a detail in the course quiz.
Ah, yes.
Notice what role is not in that list.
Yep.
A traditional development manager is not a designated actor in this pipeline flow.
Nope.
The development manager might handle HR or broad strategic resourcing, but they do not act as a gatekeeper in the CI/CD pipeline.
Right.
The actors are strictly the developer SCM, CI server, quality manager, and delivery manager.
The pipeline relies on precise roles, executing precise functions, whether those roles are played by a human being or a machine.
Which provides the perfect transition to the final, most advanced concept of our deep dive today.
The big one.
Up until step 4, the CI build, we are clearly operating within the realm of continuous integration.
Yes.
But steps 5 and 6, the acceptance tests and the manual deployment, bring us into the realm of continuous delivery.
Correct.
But there is a third, heavily debated term that gets thrown around in enterprise architecture: continuous deployment.
Yes.
What is the actual mechanical difference between delivery and deployment?
It fundamentally comes down to the boundary of trust and exactly where the automated system stops and human intervention begins.
Yep.
Continuous delivery, what we just mapped out, means that any change that passes the CI tests and the comprehensive acceptance tests is immediately ready to be deployed to production.
Ready, but not there yet.
Right. It is technically sound, is qualitatively verified, it sits there in a polished, shippable format just waiting.
It's waiting for step 6. It's waiting for the human delivery manager to manually push the button. Continuous delivery still demands a conscious, manual release decision.
Correct. But if we connect this to the bigger picture,
Mm.
what happens if we decide that human is too slow?
Yeah.
What happens if we automate the humans out of steps 5 and 6 entirely?
Wait, if we remove the quality manager from triggering the tests and we remove the delivery manager from approving the release?
Yes, if you fully automate those roles so that a successful CI build automatically triggers the acceptance tests, and a successful acceptance test automatically triggers the deployment straight into the live customer-facing production environment without a single moment of human approval.
Wow.
You have achieved the apex, continuous deployment.
That is wild to think about in a legacy enterprise context.
It's a huge leap.
I mean, a developer writes a line of code on their laptop, commits it, and within an hour, purely based on the judgment of automated test scripts, that code is live, touching real users, executing real transactions, zero human intervention.
It requires an immense, almost unfathomable level of trust in your automated testing suite.
It would have to.
Your tests cannot just be good enough, they have to be flawless.
Flawless.
They have to cover every conceivable edge case, security vulnerability, and performance metric. Continuous deployment relies completely on the A and the M in the CalMES framework.
Automation and measurement.
Bulletproof automation and relentless measurement. If your tests have blind spots, continuous deployment will simply automate the destruction of your production environment.
Bringing this right back to you, the listener, as you look at your own SAP BTP landscape, you have to map out this exact 6-step flow for your organization.
I really do.
You have to identify who or what is playing your specific actors, and you have to make a very hard, conscious choice.
What's the choice?
Are you aiming for continuous delivery, where you still maintain that safety net of a human delivery manager pulling the final lever? Or is your engineering culture and testing rigor robust enough to push all the way to continuous deployment?
You have to relentlessly optimize your testing coverage to even consider continuous deployment. But for organizations that achieve it, it is the ultimate North Star of agility.
All right, let's take a breath and recap the massive amount of architectural ground we've covered today.
We covered a lot.
We started by diagnosing the historical friction between dev and ops, recognizing that DevOps is not a software suite, but a cultural shift from functional silos to cross-functional product value streams.
Yep.
We utilized the CalMES framework culture, automation, lean, measurement, and sharing as our diagnostic tool to build a positive failure culture and enforce systemic automation.
Crucial stuff. We
drilled deep into the 3 non-negotiable CI principles, relying on version control as the single source of truth, protecting the sacred mainline by testing every change in a cloned replica via a voter build, and the absolute mandate to commit early and often to avoid catastrophic merge conflicts. Finally, we traced the exact 6-step CI/CD process flow, explicitly defining the actors and establishing the critical boundary between continuous integration, delivery, and the fully automated reality of continuous deployment.
It is a comprehensive blueprint. If you implement these mechanics, you fundamentally change how your organization delivers value.
You do. But before we sign off, we want to leave you with a final provocative thought to mull over as you begin restructuring your own pipelines.
Yeah, think about this. We strive to automate the quality manager and delivery manager roles to achieve true continuous deployment. We crave that speed and efficiency.
Yeah, truly.
But as our BTP pipelines become entirely autonomous, Executing complex builds, tests, and deployments at lightning speed, does the human role eventually transition from being a gatekeeper to merely an auditor?
That's a shift.
And more importantly, if a fully automated continuous deployment pipeline deploys a flawed update that slips past the tests and takes down a live production environment,
Hmm.
who is fundamentally responsible?
Wow, good question.
Is it the developer who wrote the initial flawed code? Is it the QA engineer who wrote the automated test that failed to catch it? Or is it the architect who proudly removed the human from the loop in the first place?
Think back to our restaurant analogy at the very beginning.
Yeah.
If the waitstaff is entirely replaced by a high-speed automated conveyor belt and a customer gets served the wrong dish, who does the customer yell at?
Exactly.
The chef who cooked it, the engineer who designed the belt, or the manager who installed it to save time? It's murky waters indeed.
Very murky.
Thank you for joining us on this deep dive into the architecture of DevOps. Take these blueprints, look closely at your SAP BTP landscape, and start figuring out how to take those swinging doors off the hinges. We'll catch you next time.